You're a clever person. You know a hole when you see one. This donut has a hole in it, and this straw has a hole in it. It's just a longer hole. This wall has 2 holes in it, and this cup only has 1 real hole, through the handle. This looks like a hole, but it's actually just a dead end. Today, I won't count that as a real hole because it doesn't go all the way through. But is a portal a hole? The answer is obviously yes, right? You can go through it. It's definitely not a dead end. But does this wooden block have a hole in it? You can go through it, but it's still solid. Where is the hole? In fact, isn't the whole point of a portal that you can go through a mountain without having to put a hole in it? Today, I want to try and answer the question, what is a hole, once and for all? Will I succeed? Probably not. Okay, let's start with something simpler. How many holes in this wall? 1. And if you wanted to put another hole in this wall, you'd need to knock some bricks out, right? It wouldn't be easy. But what if your friend Barry stands in the hole? Now how many holes? Is it 1, because you haven't actually done anything to the wall? Or is it 4, because there are clearly 4 holes, they're just smaller? Or what about this? This isn't a real through hole because it's not surrounded on all sides. So what about this? This feels like a real hole, even though it's not surrounded on all sides by wall. And what about this? Has Barry turned this fake hole into a real hole just by leaning against it? These seem like silly questions, and I can tell you the answer. The answer is, obviously, it depends what you mean by hole. But what do we mean by hole? We can't really go any further until we all agree what hole really means. Let's take a look at something similar. This hoop has 1 hole in it. Okay, what if I put it underwater? Does it still have 1 hole in it? Well, I mean, we can still go through it, so that's kind of a hole. But on the other hand, it's filled with water, so maybe that doesn't count. Or what about this ice block? You can still see the hole, right? You can still see through the hoop, but it's solid ice. And what about now? It doesn't look like there's a hole. Well, either there is still a hole or it must have disappeared at some stage along the line. Maybe it disappeared as soon as things got solid. But then what about honey? Is there still a hole now? Does it matter how sticky the honey is? Okay, maybe it disappeared once we filled it with water. But then what about smoke? This still has a hole, right? But you can also get holes in smoke. In fact, you can also get holes in water. And holes in water in a holes in a hoop. So maybe holes are part of objects. In which case we just need to know which object we're talking about. So this bamboo hoop still has a hole in it. We've just put some hay in the hole. The bamboo is part of our objects, the hay isn't. Then all of these bamboo hoops still have holes in them, regardless of what's going on around them. We could even bury one underground. It still has a hole in it, really. But on the other hand, maybe holes are a part of space. In which case we just need to make sure we know what counts as space. So let's say we can go through water and smoke, but we can't go through honey or ice. In which case, only some of these shapes have holes? So which is it? Are holes a part of objects, or are they a part of space? And are these two things really different? If we look back at Barry again, we can see where the confusion is. The wall has 1 hole in it, and Barry has no holes in him, but there are still 4 holes in space. Hang on a second, holes in space? What does that mean? Are portals holes in space? We'll come back to that later. For now, let's make things simpler. We'll have our object on its own, surrounded by empty space. Here, space means, like, empty space. All the stuff that is in the object. The question is, does it make a difference how we think about holes? Is the hole a part of the object, or a part of the space? What even is the difference? So far, we've been looking at through holes. Holes that go through an object. But this here is a gap. The wall is separated into 2 pieces. Gaps are still real holes, they just cut all the way through rather than poke all the way through. Sometimes people don't like thinking of the 2 pieces as being part of the same object, but I don't think it's that weird. Like, these are both part of the same tree. The thing to remember is that there's always 1 more pieces than there are gaps. So this snake is in 1, 2, 3, 4, 5 pieces, and there are 1, 2, 3, 4 gaps. Okay, so maybe you're not convinced by the whole part of object or part of space thing. So let me put it a different way. Generally, we think of a hole as something we can go through, and the object is the bit we can't go through. But when we're walking on a bridge, we get the opposite feeling. The bridge is the bit we can walk on, and the hole's the bit we have to walk around. And this hole means we have to jump over it. There's no way to walk over. So here's a hole we can walk through, but then as soon as we come up here, we've swapped it around. It becomes a hole that we can't walk on. When you actually think about it, it's pretty strange, right? That holes can either be thought of in opposite ways, either as something that allows us to move, or as something that prevents us from moving. Can we do anything with this? Okay, let's start off in 2D. We have a gap in our bridge, which is a connection in the water. The bridge is our object, and the water is our space. But from now on, we'll want the water to go all the way around our bridge, so that the object isn't touching anything else that might cause confusion. Now, each piece of the bridge has a loop of water around it. Each time we add a new gap, we get another loop of water around the new piece. So, gaps in the object create loops in the water. The weird thing is, this also works the other way. A loop in our bridge creates a gap in the water. This bit of water isn't connected to this bit of water. But why does it work both ways? Well, we can swap around, so our bridge becomes water, and our water becomes bridge. So a loop in the water created a gap in the bridge. Now a loop in our bridge creates a gap in the water. It works both ways. But there is one annoying thing. Remember, we always want the object to be surrounded by space, or water in this case. But this means that the space will always have one extra loop in it. That's why there's a +1 down here. So it almost matches up, but not quite perfectly. In fact, even if our object has no gaps in it, we still want the water to go around the outside. So even with 0 gaps, we still get one loop. Here's a bigger example. We have a loop in the bridge, which creates a gap in the water. Here's another loop in the bridge, which creates a gap in the water. Here's a gap in the bridge, which creates a loop in the water. Here's another gap in the bridge, which creates another loop in the water. And this bit, okay, it's a loop in the bridge, which creates a gap in the water, but it's also a loop in the water, which creates a gap in the bridge. So loops in the object are gaps in the space, and gaps in the object are loops in the space. But what do I mean when I say loops? Well, when I say loops, I really mean through holes, right? Something like this. It's just easier to think of it as being a loop in 2D space sometimes. So what this really means is that the holes in our object are also holes in our space, which is really weird. This idea is called object-space duality. Duality means two opposite ways of looking at something that give us the same thing. Basically, by swapping between thinking of object and thinking of space, we just swap how we think of the holes, either as parts of our object or as parts of our space. But we still get the same number of holes either way, except we always get an annoying extra hole in the space. If you're confused by what I mean by holes in space, you can think of the space as being an object, like the water here. So for example, this is a gap in the water. It works for one-dimensional objects too, but it's a bit different. This time, gaps in the object create gaps in the space. So this bridge has 2 gaps, and the space has 1, 2, 3 gaps. Annoyingly, we still get this +1 in the space. Can we get rid of it? We actually can, by turning our one-dimensional line into a circle. It's a bit of a weird thing to do, but now we have 3 pieces of bridge and 3 pieces of water. So things are kind of more symmetrical, and duality works a lot better. If we do this, we can get rid of the +1. We can actually do the same thing with our 2D shapes. We've mapped the ends of our one-dimensional shape to get a circle. Well, we can map the ends of our 2-dimensional shape to form a sphere. What? Why did I do this again? Okay, so we have this annoying extra hole in the water, a through hole in the water. But if we turn it into a sphere, now we don't have an extra hole in the water. Can you see why? It looks like the water still has a hole in it, but now if we try and go through the hole in the water, we'll find it's actually a dead end, which doesn't count. If you don't understand that though, don't worry. We're going to go back to normal now anyway. And for the rest of the video, let's just agree to ignore this annoying extra hole. So to recap, object-space duality tells us that holes in objects match up with holes in space. They are 2 ways of thinking of the same thing. By the way, object-space duality is also called Alexander duality, which is named after a guy called Alexander Duality. But how can we use it? Well, for example, one loop in our object means one gap in our space. So if you draw a squiggly loop on a piece of paper, then it always separates the space into an inside and an outside. Which feels pretty obvious until you see something like this. The fact that this has an inside and an outside that are separate from each other isn't so obvious. But it's still one big loop, so it must be true. Another example is with mazes. Let's say there's exactly one correct way through your maze. Well, that means there's one extra loop through the space, which means there's one gap in the object, which is in this case the hedge. And one gap means the hedge is split into 2 pieces. Neat. Things really start to get interesting though with 3D objects. This might look a bit scary, but it's not that different to 2D. Let's go through it step by step. First off, we have a new type of hole, sealed spaces, that look like this. You have an inside space, and it's sealed off from the outside space. These are still real holes. If an object has a sealed space in it, then the space has a gap in it, i.e. it's like split between the outside and the inside space. This is like what we were looking at for loops in 2D. Then let's skip the second line for the moment, and we'll see that gaps in the object create sealed objects in the space. What do I mean by that? Well, if we create gaps in our object, then the space has sealed objects in it. You can think of the space as being water again if you like. Then the water has 3 holes in it. They're just currently being taken up by sealed objects. Sealed objects, by the way, is the same thing as a sealed space, just with objects in space rather than space in objects. Okay, the middle one is the most interesting one. Through holes in the object are through holes in the space. What does that mean? Have a look at this donut. It's a solid donut. And clearly it has a hole in it. We tend to think of it as something we can go through. Then we can loop back around and end up back where we started. This looping back around is actually really important. For example, this looks like a through hole, but if we go through it, then we get stuck. We can't loop back around without going back out the way we came. So this is just a dead end, whereas this is a through hole. But there's another way to think of this hole, and that's to see it as a loop in the object. But hang on a second, seeing it as a loop in the space or as a loop in the object, both of these ways are doing the same thing. To see what I mean, let's swap the object with the space. So the space is going to become solids, and the object is going to become air. Now we get a donut-shaped room. How many through holes in this room? Well, it's 1. We can go through here, round, and end up back where we started. We still get 1 through hole, even though we've swapped everything around. So often it's useful to think of our object as a space. And this little pumpkin inside, that was me a second ago. This pumpkin can walk in a loop, so it knows there's a hole there. And I can also fly in a loop, so I also know there's a hole there. We're both looking at the same hole in different ways, but both of us are counting loops. This is why we say that through holes in space is the same as through holes in the object. Here's another example. There are 3 ways to go through this object, and there are 3 ways to loop around the holes. Easy. One more example. This is like the donut earlier, but now it's hollow inside. So first of all, it's got a sealed space in it, so there's a gap between the inside space and the outside space, obviously. Now let's count the through holes. I can loop through there and come back round, that's 1 hole. And the pumpkin can also see this hole. It loops around through the object. But we have another through hole inside. One that starts here, goes round, and ends back here again. The pumpkin also sees this hole, but there's a loop in the object. It can go round the outside. So both me and the pumpkin count 2 holes total. Basically, you can either go through a hole or you can walk around it. So even in 3D shapes, duality still works. Holes in the object are holes in the space. They basically mean the same thing. The thing is, duality can't work all the time, because what about portals? These are holes in space because you can go through them, but there's no hole in either object. But duality says that holes in space and holes in objects are the same thing. So why isn't duality working, and what does this mean? First of all, there are a couple of weird ways to break duality. For example, you can make shapes where things get infinitely close to each other. It's like this. This wood block gets infinitely close to this one. They don't really touch. And similarly, this water gets infinitely close to this water, but they don't touch. You need to watch out for weird things like that. Also, unsurprisingly, infinitely big shapes can cause problems. But infinitely big shapes are a topic for another time. Just imagine this shape is infinitely big, by the way. These are, kind of important, but I don't really care about them today. Let's look at something else. Have a look at this tree. It's been chopped down, so it has a hole in it, a gap. We can think of this as adding a space in between the parts. But instead, let's think how a pumpkin living inside the tree thinks about the hole. Well, it just means that it can't get home to its friend over there. The parts of the tree are no longer connected together. In fact, we can move the pieces around as much as we like. We still haven't connected them together, so there's still a gap there. So the gap doesn't depend on distance, and it doesn't really depend on the space in between. It just depends on the fact that there is no connection. So here's the big idea. What if we put 2 pieces next to each other, but we didn't connect them. The tree is still in two different pieces, so does that mean the tree still has a hole in it? In a sense, yes. The space doesn't have a hole in it, so you can't fit through the gap, but the pumpkin can't get out of the purple room and into the yellow room. So, is this a hole? And I know what you're thinking. I thought we were supposed to be talking about portals. How has this weird tree got anything to do with it? Well, this is two things which are next to each other, but aren't connected. Whereas portals are far away from each other, but they are connected. In order to go any further, we need to understand connectivity. For example, we might say that this object is connected, because when we push it, everything moves together. If I put a hole in it, then it's no longer connected, because each piece moves separately. This one looks like it's connected, but actually it's not. The honey doesn't stick to the slime. It's actually in two different pieces. All of these three shapes look the same from the outside, but as objects, they're split into different numbers of pieces. In this way, connections inside of objects can make a huge difference to how they act. But how does this relate to holes? Well, so you have a tree, you put a hole in it, poof. Then you can stack the pieces however you like. This tree still has a hole in it, even though there's no space in between, because the pieces aren't connected. And so this tree has two holes in it. And you might be thinking, what if the lugs are nailed together or glued together? How does it make a difference? Well, here's the thing. We just need to decide what we want to count as connected and what we want to count as not connected. Just like how earlier we had to decide what counted as our object and what didn't. It depends how you look at things. Normally, we'd just say that if two things are next to each other, then they're connected. But actually, it's often helpful to have a different definition of connectivity instead. Look at this piece of string, for example. It doesn't have a hole in it, obviously, and you can wiggle the piece of string as much as you like. You won't put a hole in it unless you get a pair of scissors. In fact, you could even put the two ends of the piece of string next to each other. You still haven't put a hole in the piece of string because you haven't used any scissors or anything. Imagine a pumpkin inside our string. It can move this way, and it can move that way, but it can't do any loops, so there aren't any holes. With this one, it can still move along the string, but it still can't complete the loop, because these bits aren't connected together. So it thinks the string doesn't have any holes in it. Which makes sense, because it doesn't have any holes in it. We haven't cut anything. But there is a hole in the space, which is weird. By changing how we think of connectivity, we've made a hole in space that isn't a hole in the object. We've broken duality. Or look at this. We lay the string out and then over itself, but there's no connection here. So the string doesn't have a hole in it, even though there is a hole in space. One more example, a rubber band. This time the pumpkin does think there's a hole, because it can move all the way around and make a loop. What if we clump up the rubber band? Well, it still only has one hole in it. The pumpkin still has to go all the way around. It can't jump across because there are no connections. In fact, even if we clump it into a small ball, we haven't changed any connections, so the band itself still has one hole in it. The pumpkin still has to walk all the way around. Even if we twist the bands, we get two holes in space, but the band itself still has only one hole in it because this bit isn't connected. So basically, we used to think that holes in objects and holes in space meant the same thing. But once we start messing around with connectivity and changing connections, then this just doesn't work anymore. Object-space duality just doesn't fit in with our new view of the world. In fact, we've seen this since the beginning. Barry broke duality just by standing in a hole, because in terms of the objects here, there is only one through hole, and that's a hole in the wall. But there are still 4 through holes in space. And why is that? Because Barry isn't connected to the wall. He's just touching it. Unless somehow he's fused himself to the wall and has become some sort of half-man, half-wall hybrid, but that's unlikely. The point is that messing around with connectivity has broken duality. We have holes in space without having holes in objects. And now the moment we've been waiting for. The thing to realise is that once we've already started messing around with connectivity, the idea of connecting two things that are far apart isn't that much of a stretch. I mean, why not? This is a portal that connects part of space to another part of space. So this is a hole in space, but not a hole in an object. The objects themselves are both solid. In fact, the crazy thing is, we can create portals without any sort of object whatsoever. It's a hole in space in the most general sense, a hole in the total space that we all live in. is a hole in the fabric of space itself. This completely breaks duality. We can create holes in space without having to work with objects at all, which is weird. I think a lot of people, if I were to ask them what a hole is, they'd say it's something that's missing in an object. But nothing's missing here. It's a hole without any object at all. Not all portals are really holes though. Here's an example where it looks like we've made a through hole, but actually it's just a dead end. But in order to make it a through hole, we'd need to connect the space together to be able to go round in a loop. Although, again, it depends what you mean by space. It's not a hole in the space we can move through, it's just an extension of our available space. While it is still a hole in total space, as in, the fabric of the universe. So far, we've been looking at holes in space, but we can also connect objects together. It looks like it's two different pieces of string, but if you look at it carefully, they're actually both the same piece of string. So there's no hole in it. Even though there is distance in between it, we need to look for the connections. In fact, we could shrink the portals, and the string would still be connected. It's just harder to see how. You can imagine the pumpkin walking up and down the string. As far as it's concerned, the whole thing is connected. It doesn't care about the outside space, so there is still no gap in the piece of string. We can also make a loop through a portal. This makes a through hole in the object, because a pumpkin can still walk all the way around in a loop, like back to where it started. So technically this is still a through hole in the object itself. In fact, this is the same thing. It's still a loop. It looks like it goes on forever, but that's just because it's repeating. It repeats in the same way that a normal loop repeats if you follow it around. And so, since it's a loop, it technically has a hole. These two things aren't that different. We can even shrink the portals so that only the string goes through. You can imagine trying to pull the string out of this portal, but you'd also be pulling it further into this one. So now there's no hole in space around it. But there is a hole in the string. But wait, what? How can this be a hole? What even is a hole again? Remember, normally we think of a through hole as a loop through space, but we can also think of it as a loop through an object. And actually, there isn't that much difference between space and object. They're both basically just shapes. So we can talk about holes in space and holes in objects. And it's not clear which one makes more sense to call a hole. On the one hand, loops through space feel like holes, but it can be useful to talk about holes in objects, like with our pieces of string earlier. I want to say that this piece of string doesn't have a hole in it. Really, we can mean two different things when we say hole, which is weird and probably not something you'd thought about before. In a way, our answer hasn't really changed since the very beginning. It depends what you mean. But hopefully now you can understand why we have two ways of thinking of holes, and why they're both asking the same question but from different perspectives. So, to recap, there are two ways of thinking of holes, either as parts of the space, which you can go through, or as parts of the object, which you have to walk around. And object-space duality tells us that it doesn't matter how you think about holes. The holes are both parts of objects and parts of space. In fact, they're both holes in objects and holes in space in a sense. For example, with this hole, we can either loop through the space to count it, or we can loop through the object. Both ways of looking at holes count the same thing. But this doesn't work all the time, and it certainly doesn't work once we mess around with connections. So for example, this object has a hole in space, but it doesn't have a hole in the object itself. And we can do the other way too. This has a hole in the objects, but it's not a hole in space. Once we start to mess around with connections, holes in objects and holes in space no longer mean the same thing, and it's not clear which one we should be talking about when we talk about holes. The big idea is that holes are all about connections. To understand one is to understand the other, and connections are more complicated than you might expect. There's still a lot more to say about portals, but it will have to wait for another day. Until then, I've been Limited Fun. Remember to subscribe to my channel below. See you next time, goodbye.